Welcome back, everybody. In today's video, we're going to talk about RTUs again. I'm going to get a little bit more into detail, discussing water intrusion, how it gets into the building, some of the things that we need to be watching out for when we're wiring these things up and when we're installing these so that does not happen. Also, explain a little bit more about that second circuit, that Y1, Y2, and how when they're both not running in the proper sequence, they can put humidity back into the building. I hope this video helps you out. Stay tuned. Okay, so we have a rooftop package unit behind me. I'm going to go over some of the components in here. We have the unit itself, a couple of fan motors. We have two compressors, Y1, Y2. We have our belt-driven blower wheel motor belt combination. We have our three-phase heat strips and our evaporator coil where there's two circuits. You have Y1 circuit, Y2 circuit. We have our condenser coils over here, compressors. We have our curb, and then obviously anything below that will be the roof deck. And we're going to get right into it. We're going to go over common issues. Common issues on these are refrigerant leaks, dirty coils, corroded coils, installation errors where maybe when the package unit was installed, they didn't line up the supply and return air plenum correctly, so they could be backwards or they could be partially covered up. Sometimes these units, they wind up getting upsized due to the demand for more cooling capacity. And these plenums do not get upsized with them, so we experience a lot of flood back on these compressors where liquid refrigerant migrates back to the suction on the compressor, losing oil, killing compressors. Motors not turning at the proper RPMs and belts flopping off. Belts not being aligned properly, so they're not riding just right, so they start to ride on their edge and they flop off. Obviously, heat strips, they're not fused properly, so a lot of times we see these things not even connected. We have fresh airs that aren't installed, and when they are installed, they're just either all the way closed or they're all the way open. They're not in the proper positions. Condenser fan motors that go out, they get replaced. They don't go back with the proper RPM and horsepower, so we don't turn at the proper RPMs and get that right amount of airflow. So we have pressures that are higher than they're supposed to be. That in combination or coupled with anything else with the high heat index on the roof and the already high ambient temperatures in the summer, these things just run pretty hard. They run pretty inefficient, and they start causing problems. They start having a lot of pressure switches that wind up tripping. You see a lot of people, they wind up bypassing these pressure switches instead of actually fixing the issues that are causing those switches to trip as a safety. There's just, we can keep on going. There's these units that get installed. The electrical should be coming out of the roof deck, going to a disconnect box, and then out of that, an electrical whip should be going into the unit. And then we should be feeding our electrical panels, not coming through the bottom of the package unit, and then siliconing them, because as water comes into the unit naturally from the tops of the condenser section, water can pull up in here, and if the channels that are inside these units to allow that water to drain out are clogged with anything, just debris, by not having proper maintenances, that water just kind of sits in there, accumulates, and that could even leak down. These curbs could be leaking. Obviously, the roof itself could be leaking because screws get dropped on the roof deck. That membrane winds up getting a hole poked in it because somebody's stepping on the screw. Seeing a lot where the panels don't get securely fastened, and then wind comes in and pushes the panel off. Compressors overheat as a result of that, or over here, coils will freeze up. We can go on and on and on and on and on. I think because a lot of this stuff is up and out of the way and out of sight and out of everybody's mind, I believe that people just get careless and they wind up taking shortcuts, and they're not very careful about putting things back together and looking at what needs to be taken care of and taking it very seriously, because everybody relies on that unit up on the roof to run and the technician going up there to know what he's doing. However, not many people are actually going up there to even inspect the equipment that has been supposedly cleaned or worked on correctly. So we see a lot of these rooftop units that are just in disarray. They're just, have a lot of issues. The amount of money that it costs to replace one of these is pretty up there, and they're not just readily available. When you get into these higher tonnages, they're just not available as fast as you need them. So it's very important to be able to make sure these things are running properly for your client. Getting right into other things, the blower motors. If you have to replace a blower motor, you don't have to go back with factory motors. You can go with an aftermarket motor as long as it's within the specifications and you wire the voltage correctly, whether it's high voltage or low voltage. Low voltage meaning 208, 230, high voltage 460, 480. In the event that these motors are wired wrong, you wind up having issues there. These shafts, a lot of times there's little grease ports on them where you can take a grease tube and you can actually pump some grease into them to keep these bearings lubricated so they turn. And as that friction picks up, as that shaft is turning because of the pulley and belt, the whole system here is running. You want to make sure that it's not causing any excess friction that would be as a result of bearings seizing up or the blower motor just, having too much vibration on it that could cause that wheel to separate. See that a lot too. So proper maintenance is key to these things functioning for the longevity that they were designed to function. Pressure switches on the compressors, as I mentioned earlier, they wind up getting bypassed instead of keeping them in circuit and just solving the issue that's causing the switch to go out. The most common switch that actually trips the most is actually the high pressure switch, and that high pressure switch is always one that gets bypassed. And that's something you got to think about. Why is the high pressure switch tripping? Is the unit overcharged a little bit? Has it been worked on? Has it been serviced and had Freon added? Are these coils not clean? There's reasons why these things are tripping. These things were built to be on top of a hot roof, and you're not supposed to have to take refrigerant out of them or alter the amount of refrigerant that's required to be in there. If you are working on it, you want to scale that refrigerant back in to make sure it's at factory levels. A lot of technicians are still going off of temperature splits, and they're going off of pressures, low side and high side pressures. That's not enough value to get all your information that you need to make sure the system's running properly. As a matter of fact, if you think it is, then ask yourself, when the manufacturer rep, the FR, when they come out there to inspect it, they don't just take these 3 readings. They wind up taking about 13 to 15 values, not to include amp draws and everything else. And they make you fill out all this paperwork, and they want to find out why they even need to come out there, if they need to come out there. And if they do need to come out there, they don't want to do your job. So they'll supervise these machines being worked on by a technician. These things get cut up, they get hacked up, they get bypassed. It's amazing how most of these wind up looking when you wind up inheriting an account through your good deeds and your good service and actions, and you wind up going up on the roof and you got about 10 of these things. You're always going to find 4 or 5 of them that have just been hacked up. When you see that, you need to see opportunity, not see, oh my gosh, I don't want to work on this thing, it's not to factory specs. You need to look at it and just put it back to factory specs, or at least quote it that way. And at the end of the day, I just don't think that happens quite a bit. There's always a high humidity concern. We're going to go over that in a little bit. The bottom coil and the top coil, that's your Y1 and Y2. We're going to cover that. Going into the common mistakes, A lot of people don't understand their refrigerant circuits. When we talk about Y1 and Y2, we're talking about circuit 1 and circuit 2. Sometimes these are labeled A, or they're labeled B, they're labeled 1, they're labeled 2. Sometimes your compressors are different sizes, so you might have a higher BTU on Y1, a lower BTU on Y2. You know, at the end of the day, it's however the manufacturer wanted to make that. What we see a lot of times are people will wire the Y1 and Y2 to both come on at the same time. That's a big surge in power when that thing first comes on. That's not good for the equipment. That's not good for the fuses that are there to protect that equipment. So when you look at Y1 and Y2, they're supposed to be coming on independently. Like Y1 is your first stage, Y2 is your second stage. So in the event that we need Y2 to come on, just like in residential equipment, that commercial rooftop unit's designed the same way. It's to be in addition to Y1, right? Nice thing about having two compressors is also that there's a little bit of redundancy. So if one goes down, you can have the other one. However, it doesn't always work out that way when it comes to humidity, which we'll go over that in a second. Water leaks. These things are known for water leaks, and they're known to be misdiagnosed on those water leaks. As I mentioned earlier, somebody can just step on a screw and it can be a roof leak. The curb can be leaking if the unit's not sitting correctly on the curb. If the unit has been drilled into, meaning the base plate of the unit has been compromised, then it's not going to have the integrity that it was designed to keep water out. Water will now intrude inside the building through those holes. So you may just need to put a little bit more silicone in the area that somebody brought an electrical whip up in. If you're going to bring an electrical whip up in these things, or low voltage wires in these things, you have an entire blower cavity, okay, that you can access perfectly fine, and then from there you can actually get into the control panel. You should never ever go into the condenser section of the rooftop unit and drill a hole into that thick steel bottom to run your electrical whip into. That is not the correct way. That is not what the manufacturer is intended, and that is never going to work long term for the customer. It may not even work right away. As soon as it rains or water pools up in there, you're going to have issues. So the no-nos are basically what we're covering right now. Disconnects should be on these units. Electrical whips should be either coming up through the blower section or coming up through a gooseneck on the roof, and then whipped over into a side of the unit where you can safely secure a disconnect box to where you're not going to harm the functionality of the system. It can be still serviced and you're not going to poke a hole in the coil or whatnot. So we're going to go ahead and talk about the humidity concerns in the Y1 and Y2 a little bit more in detail. I'm going to move out of the way a little bit so you can see this evaporator coil. This evaporator coil is going to dehumidify the moment any moisture comes in contact with this coil, because the coil is cold. And so it's going to wind up sweating as a result of humidity. If there's less humidity, there's going to be less sweat. The more humidity, the more sweat. So you can't sit there and say, well, it's not draining water off of it. Well, the humidity may be low enough to where it's not going to pull enough water out of the air going across this coil as it would on a more humid day. However, if you wind up having a dry condition outside and you were to, say, lose Y1 compressor, circuit 1, and that compressor's off, and the only other thing you can do is just wire the system to run Y2, well, you're running the top side of that evaporator coil, and you're not running the bottom side of that coil. So what happens is all the moisture that is being collected up on this coil will now run down, and this coil is no longer cold here because the circuit is not moving any heat. There's no BTUs on this bottom of the coil. So now that water that's coming off of this coil out of the air is running down and going back into the air. So you're not really dehumidifying there. So if there's a humidity issue, check and make sure that both circuits are running. In the event that it's just out of sequence and you have your Y2 compressor as your main compressor, if that one's coming on and the Y1 compressor, you have that as your Y2, and it doesn't come on until you have a high demand, then having these coils backwards as far as the sequence goes would put that humidity back in there too. So both, you could have them wired wrong as far as Y1, Y2 if you've done work to it, or if your Y1 is down, your circuit 1 is down and you're running circuit 2 only, then that humidity that is being removed by that coil being cold, this coil being warm, okay, that water is just going to run down into it and that blower is just going to pull it right off of there, and it's just going to, the dehumidification is going to be rehumidifying the air. So you're not going to have an absence of moisture. You're not going to be doing anything with that moisture. So as we add more moisture in here, even if it's a low percentage to the building, there's no way to really dehumidify that in that situation. So we could have a humidity issue, a high humidity issue. I'm going to get into a more elaborate description of what we just went through. Here I took the liberty to draw you out a refrigerant circuit for Y1 and Y2. I'm going to kind of go over that a little bit. Forget all these numbers right now. We'll go over that in a second. Same thing. I just flop my compressors around. So I have Y2 here and Y1 here. Look, there's many names for these circuits. They're not going to label it Y1 and Y2. They may label it A and circuit B. They may label it 1 and 2. They may label it circuit 1 and circuit 2. And sometimes it's just a sticker, and those stickers can just come off, and you may not know which one is which. The easiest way to tell is your evaporator coil. At the bottom section of the coil is cold when one compressor is running, then that compressor would be circuit 1, right? And so you want to make sure that sequence is correct so you're not adding that humidity back into the building that's being pulled out. Same thing, we got our blower, we have our belts, heat strips. Looking at our refrigerant circuit, it's just a straight cool. I did not really feel like putting a heat pump up here. That'd be a little bit more piping, and I think I would only busy this up and confuse you. This is not a diagram to show you the path that the refrigerant's taking from point A to point B, condenser to evaporator. This is just really to illustrate, that these circuits, if I have red and red and blue, then that basically means that, we're running. So I'm going to sit here and show you that if we had a problem with what I'm talking about, let's just say say we had an expansion valve here that was not allowing refrigerant into this coil. So now the coil is not, give me a second here. Oh, come on. There we go. So let's just say that coil, I'm turning it white here, because if that valve is bad, then over here, we have a high head pressure. We're starving the coil of liquid refrigerant, so the returning gas is going to be at a low pressure, high subcool, high superheat situation. Not to really get into that, but if this was the case, then the water that is collected on this coil at 46 degrees will run down onto this coil, which is sitting at around room temperature, 75 degrees, and the humidity that is removed up here, it's just going to be added back to it, and meaning you're not removing any moisture. You may be getting some of the heat out of the building, but you're not going to be getting the humidity out of the building in this situation. Now, how this is supposed to stage itself is the Y2 compressor. If I can get just give me a second here, if I can get the selection to get onto the coil. Oh my gosh. Here's what I'm going to do. away some of that capillary tube so I can get my pin on that square. And so if the Y2 staged down, I'm going to go ahead and take Y2 over here. This just represents that either it's out of gas or the compressor's just off. So we're only running circuit 1, Y1, right, and Y1 over here. When you only have a low demand and you're trying to just maintain the temperature in the building, you only need the first circuit to be running. So we're running one circuit, which it can be in any combination. Typically, it's the largest compressor, right? And this is going to be fine because you can't add humidity back into the building here because the water is just running into the drain pan and out the actual RTU. Whereas the way we had it before is the Y2, if it was running and the Y1 was not running, then that water would roll down and pull back in. So this is the way that the equipment should stage. It should stage in Y1 first, which would be the bottom of the coil. Doesn't matter which one of these is Y1, I just drew it out this way. And then when you need a higher BTU, we'll go ahead and just stage it back up so it'll look like this where we're running 2 circuits. Okay, going over the anatomy a little bit more, we got the roof deck down here. I put down here a heat index of 110 because if the outdoor ambient temperature is 95 degrees, that roof deck's going to be a lot warmer. Anybody that does a lot of commercial or has done commercial knows that the roof is very hot and that heat coming off of it, it's scorching. So if I had about a 95 degree ambient and about 110 degree heat index, that is going to bear a pretty high heat load on these evaporator coils that already have hot gas going through it. But don't remove refrigerant just because your head pressure is high and all that, because you're going to have a higher discharge temperature than you are the air coming into here. So that discharge temperature is warmer than that heat index, that ambient temperature, all of that, and it's warmer than the discharge that's coming off of it. So you're cooling that down. As you cool that down, that heat is rejected out the top of that unit through your fans. And as a result of that, you'll have liquid running through the liquid line, and then that will meter, and that liquid will go into your evaporator coil, creating a cold coil. Here I put down that the return air was 75 degrees in my diagram, humidity at 49% roughly. And then of course, the longer you run, the lower the humidity in the building, the shorter the cycle, the higher the humidity. So if you have one customer that's saying, hey, the humidity is high, the very first thing I would be checking is, do both compressors come on and run? Am I running Y2 only? Okay, if that's not the case, if they both do run, how do they sequence? Does Y1 come on by itself? Or did somebody put Y1 and Y2 in the same bus bar on the thermostat or wire them together up in the control panel of the RTU where they just, they were just being lazy or whatever, and they didn't have Y1 and Y2 to where it could stage properly. A lot of times, that's just overkill and you're going to shorten the cycle. So you have your cooler months out of the year where it's warm in the day and cooler at night, and you don't need all these BTUs. So you can take any combination. If I'm running top and bottom, I just put down for my example that the Y1 circuit was 5 ton in every case, and the Y2 circuit was a combination of 2.5, 3, 4, or 5. So here I would have like a 7.5 ton, 8 ton, 9 ton, 10 ton, right? And so if I'm running everything, then at any point in time, I'm going to have a situation to where every now and then when that outdoor temperature drops, I'm still running too much BTU, so I'm going to transfer heat at a very fast rate. And if I transfer heat at a very fast rate, I'm going to satisfy very quickly. So everything could be working great as far as refrigerant in the system, and the system being very clean and able to transfer heat. But if you're running wide open, full demand, Y1 and Y2, A and B, 1 and 2, circuit 1, circuit 2, then you're going to have too much demand and you're going to shorten that cycle, and that will cause a humidity issue. So, if everything's working correctly, then, meaning that the compressors are coming on and there's gas in the system, then I would be looking at, does my Y1 and my Y2 come on every time the system needs to come on? And a simple way of doing that is, one, you can look at the wiring to see if anything's just been tied together, right? That's very common. Or go to your thermostat. You can pop the plate off and to see if it has a Y1, Y2, and it may not. Maybe everything's all crammed in the Y1, right? Or maybe they have a Y1 and Y2 jumper, right? But if that's the case, undo all that and make sure your thermostat is able to stage based off the demand. So if we start slipping away, with more than a 2-degree demand from set point, then it will naturally, the thermostat should naturally call for Y2, and then you'll naturally kick in more BTUs, being able to transfer more heat out of that building. So I've got Y1 down here, Y2 here. I do have a fresh air damper. I just put the same 95-degree outdoor ambient temperature that we have. If that's pulling in across that fresh air, I put down here open at 10% or less, right? You don't really need to open them up too much because, this whole entire blower cavity is in a negative pressure, right? And so with that, it's leaking air, right, all over the place. So it's already pulling in outside air, but as it leaks air all over the place, it's not leaking air in the correct direction. You're not pulling that air across your evaporator coil. You're pulling it all over the place. So here you're controlling that air to move across a cold evaporator coil, which I just put up here as an example, 46-degree coil. Any humidity going across a cold coil is going to sweat. Now, if you look at my humidity here at 49% and my humidity here at 48%, it's not a dehumidifier. It is not here to remove a bunch of moisture. It is there to remove heat. These things are not spec'd out to run and dehumidify like these residential units that can actually stage themselves down as an inverter compressor naturally does. As it unloads, it runs longer and it targets that comfort that you're looking for by removing that moisture through length of run time. These units don't have that technology. They're commercial. They're built for a high heat load. If there's a low heat load, typically half the unit runs, half the unit's capacity, that is. And then it runs the other half of the capacity, or whichever combination you want to look at, right? When there's a higher heat load. So there's no direct concern or controls for dehumidification, right? And so that being said, they can only remove so much moisture. So you have to be very careful not to add moisture to the building or have these things running out of sequence. Rooftop package units, very known to get humidity in the building because things just are not done correctly. A lot of negative pressure that's causing that as well. So I have 49% relative humidity here going across that 46-degree coils, right? Obviously we're transferring a lot of heat, but we're not really removing a lot of moisture. So I just dropped it like maybe 1%, which is fine. Because if I had a room temperature of 75 degrees and the humidity was below 50% in a commercial building, I'm saying, hey, you're good to go. What else do you want? What else do you want? You're doing pretty good there. So nobody can really be picky there in a commercial application. If they wanted this to run any lower of humidity, I know you don't want to hear this, may sound a little crazy, and it's going to be very expensive, run the heat strips with it. You're going to create a longer run cycle because you're adding heat to the building, right? And when you add heat, as I cool air down to 55, I'm going to warm it back up to almost 75 degrees. And so now the only thing I am doing is removing moisture. And it's going to run forever. And so the heat strips will dehumidify by themselves. The coil's dehumidifying, plus the length of run time, it never cycling off, will be a third way of dehumidifying. Do not do that. That is not what I'm recommending. But there's other ways to skin a cat, as they say, and I'm just throwing that out there for educational purposes, right? Pretty much that's everything in a nutshell. No point in going on and on and on about this. We have another video that I've released on RTUs. I'll go ahead and give you a sneak peek. Don't think that these videos are the same. They're not. This is just a little bit more on a single stage. And then we talked about the negative and positive pressure and how that affects. And so definitely check that video out. It is different. I'm going over different things. There are some similarities in the event that you're not fully understanding one. Go to the next one because I just elaborate a little bit more. You know, this is something that I enjoy doing. I like educating the community. I believe that it is our job to pass on what we know and to also leave equipment better than we found it. And I think if you can accomplish both of those, I think you're doing really more than you should, right? You're not there to be a hero, but if you can be one, hey, why not, right? And that's what people like. That's what people want. So you'll be respected in your community. You'll be valued at work. Your peers will look up to you. And, you know, that's a great feeling. It's an accomplishment in our industry because not everybody can be that, right? Because some people have a different background that we bring to the table. Some people have a different way of learning. And most of us are in this trade because we learn hands-on. The way I like to teach is not so much at the equipment because as you can see here, this is very simple. I can control what I want you to see by me simply just drawing up some images. And if I wanted to take you a little bit further than that, I can just continue to draw things. But then the more I put up here, if I were to snap a photo and just put that up here, just kind of not really put the effort in, anybody can do that. I can take a picture and load it up and put it up here as an image. And you may want that. Maybe you learn better that way. Leave a comment. I'll happily try to oblige you. But in my opinion, and I built a lot of technicians, you know, the busier we make this, where's your brain? What are your eyes following? What are you looking at? You know, the more information I put up here, the more data, the more specs I put up here. You know, it's like if I were to write down the measurement of this, who cares? You don't need to see the wires. You don't need to see contactors. That's not what this class is about, right? And so whatever I'm teaching, my method of teaching is to home in on that key component or key components or subject matter and try to home in on what we're talking about so we can stay on topic very simply and not me talk about one thing and your eyes are looking at a million things that have nothing to do with what I'm talking about. Everything behind me is what we're talking about. So that's just my style of teaching. If you want me to do anything else that may help you out, listen, I'm here for you. I care about this and I want to make sure that I'm being as helpful as possible. So one thing that you can do though is leave me a comment. Like the video, please. That helps support the algorithm. Subscribe if you haven't done so already. Share this. There's a share button right there. Pass this on to your buddy, okay? That would be you not just supporting the channel, but also supporting the industry. You may not be able to pass it on to a customer, but because, you know, we are a company and you want your own brand, we respect that. But at the end of the day, there's something you can do to the industry by just sharing this with somebody that is in the industry. As always, practice safety. Be safe, especially getting on top of these roofs. Be very careful. Tie that ladder off. Don't let it fall. Don't carry more than you can handle. Use a bucket. Use ropes. Be careful. All right. There's many sad stories where people have they're not coming back. Put it that way. They're in the ground 6 feet down because they slipped, fell, whatever the case. Be careful, all right? Practice safety. That's always paramount. Don't do anything that is not that does not feel right. And if it's always good to have two people in this environment, if you have more work to do, that really helps out a lot. Thanks again. I appreciate you guys. Stay tuned. Have a good one.